Hello, we will start with exercise 3, page 317. So we will read the problem and then we'll try to solve the exercise. Here we have the springs of 1500 kilograms car compressed 5 millimeters. When it's 68 kilograms, driver gets into the driver's seat. Okay, if the car goes over a bump, what will be the frequency of vibration that we have? Okay, so how you can see here we have a diagram corresponding to one spring in the car. This system is composed by the spring and is composed by the damper as well. Okay, this is a system that help with the vibration that we have in the car. It depends to the situation. Okay. So if we have a car that goes over a bump, okay, remember that it's like you have a tire here, and imagine that we have a bump in this position, right? We have a bump in this position, and we have in this car 68 kilograms drivers get into driver's seat, okay? So this is a mass that is affecting the movement of this spring as well, okay? So basically the exercise, according to this situation, is asking for vibration. We know the mass of the car as well, okay? That is 1,500 kilograms. Moreover, I know that here we have a compression, that compress, okay? Something important is that if you have a measurement corresponding to distance, you need to change everything as meters, okay? So here, remember that this is simple. It's just write the measurement that you have, okay? And always multiply, I'm sorry, millimeters. Always multiply by the equivalent. Okay, I want to cancel millimeters, so millimeters will be a denominator. So here we have that in 1 meter, I have 1,000, right? I have 1,000 millimeters. What do I have to do now? So 5 millimeters multiplying by 1 and then divided by 1,000. You can write this as a scientific notation like times 10 elevated to a negative 3 meters, okay? Or just move the decimal point 3 times to the left. If you don't want the scientific notation, the answer of this division is equal to 0.005 meters. That is exactly the same, okay? Remember that if you have a mass, you need to convert to kilograms. If you have distance, you need to convert as a meter. If you have force, newtons, and like this, okay? It depends to the exercise. Great. Something important is to start with the given information, okay? The given information that we have. In this case, I have the mass of the car. I have the mass of the car that is 1,500 kilograms. I have the mass of the person, okay, or in this case, the driver. I'll write here mass of a driver. The mass of a driver is 68 kilograms. No problem with this measurement. I have both with kilograms, okay? We have as well as a given information that this spring that we have here, we are applying a force in this position, okay? We're applying a force. Let me see here, better with this. We are applying a force here in this direction, okay? We're compressing this one. So the compressing of the spring is equivalent to 5 millimeters, okay? Or 0.05 meters. This is from the original height is reducing in 5 millimeters. Why? Because the car goes over this bump that we have here, okay? Remember that we have the Hooke's law that is telling me that the force is equals to the negative of the constant of the spring, okay, multiplied by the displacement that we will represent with X or Y. It depends to the movement that we have, okay? This is the Hooke's law and will help us to solve the exercise, okay? Something important is that remember that the force is equals to the mass multiplying by the gravity that is affecting this problem, okay? So we can start calculating force, okay? So in this case, we'll calculate the force of with the mass, I'm sorry, with the mass of the driver, okay? So it's 68 kilograms multiplied by 9.81 meters per second to the second power. Okay, you can make a question like, why are we calculating the force with the mass of a driver and not with the mass of the car? Remember that spring right now basically is affecting by the mass that we have over this spring, okay? So the mass of the car is part of a system, but the mass that is affecting is the mass of a driver. This is the reason why we're calculating now the force using the mass of the driver, okay? So now I just need to operate this multiplication 68 times 9.81, okay? The result of this one with 2 digits after a decimal point is 667 0.08. Remember that if you multiply kilograms with the acceleration, so here we have newtons, okay? This is the force that we have, okay? I don't know what is the constant of this spring, so I think that this should be the first step. So from this formula, you can solve for the constant of the spring. Remember that I told you that the negative is according to the movement, okay? What we'll try to do with this negative, that the force must be positive, okay? This is what we'll try to solve with this negative that you have there, okay? So if we try that the force will be positive, so we will leave this constant of the spring positive. So I just need to move the displacement as a denominator in the other side. So we have that the force divided by the displacement, this is equals to the constant of the spring, okay? The force is something that you know now, okay? That is equals to 667.08 newtons, okay? Divided by the displacement, that's something important, okay? Displacement in meters, here we have. You can write this as a scientific notation or a decimal, whatever you want, it doesn't matter, okay? So here we have 0.005 meters, okay? Calculating the constant of this spring, this is equals to 667.08 divided by 0.005. So the answer for this one is equals to 133,416. And because this is the constant of the spring, those are newtons over meters, okay? So I have a force, I have the constant of the spring, and the exercise is asking for the frequency of oscillation, right? So remember that frequency is the inverse of the period, and the period is the inverse of the frequency, okay? Remember that period is the time that we spend to complete a cycle, and the frequency is the amount of cycles that we have in 1 second, okay? So I need to calculate this frequency. Okay, so you need to copy this formula. This is with a sinusoidal um, system, okay, in a simple harmonic motion. So the period is equals to 2 pi, because this one is corresponding to the cycle, square root of the mass divided by the constant of the spring, okay? This is what we have as the period. Okay, if the period is the inverse of the frequency, and the frequency is the inverse of the period, right now we're looking for the frequency. What do I have to do? Just substitute, okay? So here, we'll substitute here. 1, and period is equals to this. Okay, period is equals this. So now, I'll write here 2 pi square root of m over constant of the spring, okay? This is what we have. Right now, you are allowed to substitute, or if you want to simplify this equation corresponding to the frequency, okay? We can rewrite this one like frequency is equals to separated 1 over 2 pi square root multiplied by the square root of the inverse of this one. That will be constant of spring multiplied by the mass. Here we have something important that you need to copy, guys, is that this is the formula of a period for a simple harmonic motion in the period that we have a sinusoidal period, okay? And this is about frequency, really important, okay? So now, if you know the formula, what do I have to do? Just substitute, okay? But remember that now here, the mass is the mass of all the system, okay? This mass that we have here, you must be careful with this part, because it's the mass of the car and the mass of the driver, okay? So mass 1 or mass of the driver plus a mass of the car, okay? So the mass of the car is 1,500 and the mass of the driver is 68. So the mass that we will use here is 1,568 kilograms, okay? Basically, this is a variable in where probably you have a thou. The constant of the spring will be the same. It doesn't matter that it's affecting by 1, by 2, by 3 masses, okay, that you have inside of a car. 3 people, 5 people, 7, 10, it doesn't matter, okay? But now, if we try to calculate the frequency of all the system, in this case of the car, we need to include, okay, the mass of the car. Really important, okay? So now just substitute, frequency is equals to 2 pi, 1 over 2 pi square root of the constant of the spring that we found it already, that this is 133,416 newtons meters divided by the mass that we have here, that is 1,568 kilograms, okay? This is what we have. With our calculator, an advice to solve this type of exercise that so step by step, okay? If we substitute the values in the calculator, so we have that the answer for this exercise in the case of the frequency is 1.400. I will leave 3 digits after a decimal point. 1.468. Remember that frequency, the measurement that you have is hertz, okay? So this is the frequency of the spring according to the mass of the car, the mass of the driver. Remember that this will change according to the amount of people that you have inside of a car, okay? So if we have more people inside of a car, so the value of the mass, this mass will increase and is affecting the frequency, okay? So the answer for this exercise that is asking for will be the frequency of vibration is this one. So frequency of vibration in this exercise is 1.468 hertz. This is the answer that we have for this exercise, okay? This is everything. Thank you very much.